So my name is Jeremy Rollison. I'm based here in Microsoft's office in Brussels, and I am not an expert on construction products. I'm not an expert on construction. I spend most of my time in this building and other buildings looking at policy questions, mainly around the cloud, data policy, privacy, cybersecurity policy. But it's really encouraging to talk at an event like this and hear some of the same things that I'm saying in so many other contexts come up in another sector. This is one of the slides that there's very few presentations that I can give in Brussels without coming back to some of the messaging here. It was mentioned earlier, some of the industrial revolutions that we've seen and the timescale, and we can fuss about how many there's been, or if we're looking at three, the industrial revolution, the PC computing revolution from the 80s, we really identify the next big revolution from our side as cloud computing and all of the things that come with that. We've mentioned drones, we've mentioned AI, mentioned Internet of Things. I'll speak about that a little bit more. All of this is going to be increasingly powered by the cloud. What that means more practically, and for some of the sectors that we're discussing, such as construction, but whether it's finance, retail, anywhere, is you hear the words Internet of Things, cloud analytics, or big data. And what we're really talking is about the increasing amount of sensors and the sensitivity of those sensors to collect new types of data more quickly and more efficiently than ever before. But just getting all of the data is only half of the equation. After that, there needs to be analytics on top of that data. And it's only been in the past decade or so that we've seen advances in computing power and technologies that allow this analysis to occur more quickly than before. And much of that, once again, is happening at the cloud. What comes from that, though, is not just as good to analyze it, but it's the insights that we gather. So the computers can only be told to collect and analyze things, but they can't really tell you what to do with that information afterward. So again, one of the pitches that I often give is I'm not an expert in construction products. Microsoft is not an expert in construction products. We're not an expert in jet engines or in farming. But we have partnered up with a lot of those sectors to bring cloud solutions forward that are resulting in a lot of productivity, innovation, and efficiency gains in those same areas. So with this sector in mind, I think one of the experiences we've had, and I'm sure you've had more directly, is that, of course, there are a lot of different imperatives that come in even at the design phase. And that changes. I mean, much of it might seem, from my naive perspective, a bit static, where are we going to put the building, how big does it need to be, what are the client requests, but I'm certainly familiar with the regulatory space and how some of the considerations change there about energy efficiencies or zoning requirements and prioritization sometimes of building materials, what have you. You all know that much better than I do, but we're all aware of those considerations, which makes it all the more important at the design phase and the planning phase for that to be taken into account. So what we call smart buildings, again, don't feel free to criticize me if I use vocabulary that might not be used in your sector, but I know it is used in our sector. We're talking a lot about our vision in that space. And this slide, I've adapted it for the smart buildings in the construction space, but it's the same type of thing I mentioned earlier. It's about enhancing productivity, enhancing efficiency, and using the insights we gather from data analytics powered by the cloud to make that happen. What that means in your space is we're talking about operating these buildings with those insights, not just from a design perspective, but also from security perspective. Different buildings have different needs. Different clients, different customers have different needs. Different clients and customers have different data sources and look at those in different ways. All we can do is provide the solution and help drive some of those insights, but once again, it's your data, it's your things, and the insights can be powered by cloud computing technologies, but at the end of the day, this is all, even in a machine learning context, I'd be quick to emphasize, it's always human-assisted machine learning. Even if it's AI, it's still a human-assisted AI. So we recognize the thought-provoking things that come up in that space, absolutely, and there are a lot of regulatory challenges that will emerge, I'm sure, and some serious things that we should all be focused on. But I think there's a lot of opportunity there, and we're spending a lot more time on some of the positive, enthusiastic opportunities that we see. I'm going to go quickly through some of these slides just in the interest of time. The main thing you'll notice is whether we're talking about operational intelligence, whether we're talking about even some of the energy benefits that we would get from this, it's still coming back to what we see as a cloud-driven analytics insights development space. Different buildings, once again, have different needs. You know, we have a lot of partner stories. Some are large design firms, some are large construction firms, some are more specific. You know, ThyssenKrupp is one of our biggest partners, and we've done a lot with the elevator rollout that they've done and what they're learning from their devices. And once you start to team up some of these partners together, I have not focused a lot of time here on some of the implications for city development. But when you can start to see the type of data that may be collected from an elevator provider and how that can be used by city planners to prioritize public transport systems based on population increases and decreases, that can be measured sometimes much more effectively by elevator usage than by some of the traditional sensors data we used to collect in the past. And again, all of this is hopefully the buildings that we're driving, and there's an example here of what we've done ourselves, is making these buildings not just be designed differently and built differently, but then also perform differently once they're in place. Tenant applications refers a bit more to some of the specific clients we have, and I think with some of the data that we're collecting and the possibilities in this space, you know, you're seeing a lot more tailored construction and a lot more tailored design that we're really proud of, because some of the insights that are coming out of that, of course, are coming from some of our analytics and software solutions, but it's something that the clients and customers have been increasingly proud about and increasingly proud to showcase some of the buildings and applications that they're building out on top of these new software platforms. So our vision for smart buildings with those slides in mind, this puts it all in one space for you, although I don't know if you'll be able to see everything. We talked about building the operations services. There's the security and accessibility. We're talking everything from key cards to design of stairwells and parking spaces, how they're being used and how that can be monitored and improved after the building's design. And we're talking, of course, about enabling just the different type of sensors that can be there for whether it's high traffic areas, low traffic areas, office rooms that are used better or differently than others. And again, coming back to the specific client needs, which gives you a fuller picture, which the center of it is what we're most involved in, is a trusted cloud platform that we believe is driving more and more of this innovation in that space. So you see here, you're never going to be able to see all the small print, but long story short, what we have is all of the different type of smart building services that we can provide, all of the different assets and sensors that are actually driving or producing a lot of the data that then goes back to the cloud. And so everything comes back to the center. Underneath there is a bunch of different products that I'm happy to point you in the direction of some of the business guys if you want to talk about that more in depth. Some of you might already know about it. But the important thing is just all the different ways that software is now powering more and more of the design, execution, and then follow-up and commissioning of many of these buildings as well. And just as we say, we do eat our own dog food. And one of the areas that we've been really proud about, I've been to the campus a number of times just outside of Redmond in Seattle. There's over 88 acres, and there's over 145 buildings now on campus. And using our own in-house technologies to start to address some of the challenges that we had. You know, these buildings were built in different decades, different years, and some were added, and sometimes we had a contract with one provider and a different solution. So what we have is about 140 buildings, some of which are on a common platform, some of which have no platform, some of which are really old, some of which are really new. Long story short, there was a lot of efficiencies that could be gained. So once we started establishing and setting up, leveraging the existing sensors and the existing data we had, setting up new sensors on top of some of these buildings, collecting all of that back into, again, Microsoft Cloud in this instance, using Internet of Things, big data analytics to drive more efficient coordination. We developed over $2 million in cost savings a year. We've reduced our electrical consumption by over 10%, and that's improving all of the time. One other statistic is now something close to 50% of all of the engineering or problems that are alerted can now be fixed within 60 seconds simply because of how quickly, I mean, again, different problems. A roof falling is a lot different than a radiator giving a bizarre reading. But just noticing discrepancies around when peak usage times were emerging. One of the stories we often tell is it was one office building that seemed to have the highest electricity usage at midnight. Nothing that we would have ever known before without actually having some of the analytics from the platform and having these sensors established. It's not for today, but I try to keep it a little bit more at the building example, and we could spend a lot more time drilling down some of those specific services and what type of value I think it could bring to the architectural and construction sectors. But this has super implications for city planning. The data then that's collected within these buildings and from these buildings go into that planning stage. And again, a lot of times we're talking there more about sustainability goals, energy savings, and these priorities change based on different, political periods. But once again, we see the cloud having a tremendous impact on such services and on such city planning. And I've actually engaged with a lot of cities in Europe, Utrecht, Issy-les-Moulineaux in Paris, where we're rolling out already some of these solutions and seeing a lot of great results come out of that. And finally, completely separate, although still a cloud-powered technology, one of the pieces of hardware that we've released and will be increasingly rolled out that comes back to one of the points made at the outset by Pierre when we're talking about how people are communicating on site at the design phase afterward. This is Microsoft HoloLens, and I'm not sure if everyone can see it, but it's essentially a all-in-one computer kind of on your head. Now, it is not virtual reality. It's what we refer to as augmented reality or mixed reality. It's hologram powered. So imagine taking something like this, essentially putting it on your head, full computing power, everything is all inside. And I still see everything in front of me, but I can also launch applications and I can launch different programs that can rest on a table, they can rest on the wall, wherever I might like it. And one of the areas that's been the most successful thus far, and we're seeing a lot of really cool, exciting applications come out, is the collaborative possibilities and in a commercial context. So what this allows you to do is use one of those design programs, work with people, not just in the same room, but around the world, where I can launch the building design on this table here that I'm seeing through my lens. Somebody on the other side of the world will see the same thing that I'm seeing and can make adjustments in real time that I will see in my field of vision, along with those in the room around me. We can export that material to whatever device somebody has, whether they're on site, again, somewhere else in the world. And you can see just already some of the collaborative possibilities that we're really excited about. So we're working with a number of partners in that space, encouraging them to develop on top of the platform and come out with new uses. I was just speaking last week in a veterinary context of one of our developers who's using the same technologies to design animal cadavers so that students can practice on holographic cadavers first before going into the other world. One of our French partners outside of Bordeaux has created a program for training crane operators, again, with relevance to a construction sector. We were told that apparently that's a very nervous experience, managing a crane the first time. Now we can do the same thing in a holographic space, in an augmented reality, mixed reality space, really improving some of the training there. So I think the main message is that we see a lot of opportunity for data and the cloud to power the innovation in other sectors. I think we have a lot of great examples already from the construction and architectural sectors. So with more time, I'm happy to get into some of that, but I think that's enough for now about where we see some of the future.